Hi. I promised that I would do another installment of the brain, information about the brain and how it applies to our body. And um, I I was really thrilled to see so many people interested in what it was that I had to say in the last little video that I did. And um, thank you so much for wanting to know more. And so here it is. I wanted to do it live, but I just thought actually I'm going to do it by video, and you guys can post questions and I can always reply to them from there. So this first little installment, I'm going to go into it obviously deeper than I did the other day, and I'm going to break things apart a little bit more. This first installment is going to be fairly dry neural anatomy, but I think it's really important to kind of have an idea of what's up there if you want to have an understanding of how it works. So my information, as I said, comes from my studies with applied movement neurology, and their training body is based on the principles of functional neurology and neuroplasticity, and using tools to work with that to improve our training, because at the end of the day it is still about the workout. At the end of the day it is still about maximizing your body's output optimally. That's still what the training body is about, even though it's looking at it from a completely different perspective. So basically, the human brain, it is the single most complex and complete system in the known universe. Every experience that you have, movement, sight, sound, smell, every experience that you have is due to the frequency of firing of neurons in your brain, of electrical currents firing neurons and creating synapses in your brain. So the brain is the governing system of the body. It is 3-pound massive jelly that holds 86 billion neurons, and it's like the worker bee of the body. Basically, the neurons are like the worker bees of the body, and only the heart and the gut can actually fire independently of the brain, of instruction from the brain. So basically, when we're born, you're born with 2 subconscious directives. I mean, this is how all of us, we're born with 2 subconscious directives, and that is survival of the individual and survival of the species. Survival of the individual, every single person is born with one fear, the same. We're born with this fear, and that is the fear of damaging this. Everything that is built into our body reflexively, all our instincts, is all about protecting this. The rest is just a vessel to carry this around and for it to have its life experience. And I think when you put that into perspective, that this is to serve this, it becomes a little bit more obvious why how this works is so very important. Okay, so in order to survive, you need fuel and you need activation. Basically, the brain is only 2% of the whole body weight, but in humans, but it uses 15% of the entire cardiac output. It uses 20% of oxygen consumption from your body, and it uses about 25% of the glucose. So it's a massively hungry organ. It needs fuel and it needs activation. So your fuel is your glucose, your oxygen, and your diet and your nutrients. And your activation is stimulation over a lifetime, interacting with our environment. Just consider how our ancestors interacted with the environment versus how we interact with the environment. Back then, they didn't need gyms, they didn't need weights, they didn't need aerobics classes, because they were busy surviving. They were so busy interacting with their environment. Things have become so much simpler, so much easier, so much more convenient for us now. So we don't have that interaction with the environment. not the same as they did. They walked around barefoot on the earth, naturally earthing themselves. They were up, down all the time, standing, sitting, hunting in the bushes, making the fires. So really, we need to bring that kind of movement back into our daily lives. Okay, let's be realistic. It's we're not going to do that sitting at our desks. But just when you're training, you can add that into your life. And in the second installment, when we go deeper into the cerebellum, it will be apparent why. Okay, so I'm going to move on. Basically, as we're born, we are born as tiny little flexor beings, and as we develop, we start to straighten out. We start to look around and take in the world around us, and we are slowly starting to develop, and our brain develops along with that. It kind of expands out. When we get older, if we have led a life that's really quite sagittal, plain, everything very sort of same, and not a lot of interesting movement, we do actually start to revert to being little flexor beings again. And so that is why it's really important to engage with the back of the body, to engage with the extensor chain. It has to do with our brain as well. So stimulating the brain helps us to do that. All right, so basically the brain requires the body to move for survival. That's bottom line. Okay, research shows that even people who fidget have better cognitive function than those who don't. So how much we move directly impacts on our brains. 90% of all fuel and activation to your brain comes from moving your spine. 90%. That figure always just blows my mind. I've made notes because I didn't want to miss out on anything that I wanted to say. Okay, so proprioception. Basically, for the brain to have feedback from the body, we have thousands and thousands of tiny little receptors that sit in the skin, in the fascia, in the muscles, in the tendons, in the ligaments, in our joint capsules, that feed back to the brain constantly, tonically, about where we are in space and how we are interacting with our surroundings. In fact, what it does is it transduces stimuli about our surroundings, our touch, our smell. So I can interact. There is a table, I can see it. Okay, proprioception. It's temperature, pressure, pain, vibration, joint angulation, speed, tension, stretch. It just goes on and on and on. So whatever you are actually feeling is proprioception. Majority of which is subconscious. It's subconscious. You're not even aware of it actually happening. But that is feeding up to the brain, and the result is coming back down. So they considered sensory inputs going up and motor outputs going down. Basically, I'll read what I'd written. These signals are considered sensory inputs going up the back of the spine into the brainstem and then onto the brain. And then the brain responds with a descending motor output as a response, traveling down the front of the spine and then out through the ventral horns. And those little signals then tell the body what to do. There is, for every one going up, there are 30 coming back down, 30 signals, motor signals coming back down. So proprioception actually lands on the parietal lobe of the brain, on a part called the somatosensory cortex. And that holds, I'm going to get to that. I'm going to get to the parts of the brain in a second. So proprioception lands on the parietal lobe. The spinal cord has several reflexes. So this is different. Your spinal cord holds several reflexes that require minimum input from the brain, because sometimes we need to respond quickly. We're walking along, we step on a sharp object. I need to reflexively react to pull my foot away. That is my reflexes responding to that proprioception without a lot of input in the brain. There is so those reflexes from a movement perspective, there's it's the crossover, the sort of the sling, there's the gait reflex, there are several movement reflexes. that are triggered in a situation like that. But just to know that those reflexes are in the spine. Okay, so the brain, the cerebral cortex. It holds 5 lobes. There are 5 lobes in the brain. We have the frontal cortex. He is the CEO, and one of his major jobs is he recognizes future consequence from current actions. So that is logical stuff, but it's also working out movement. The parietal lobe over here, as I said, that's kind of where proprioception lands on the somatosensory cortex, but also that's where the brain houses maps of our body. So it holds a visual 3D image of our body, and it holds several actually. And for example, the sensory one, which is relative to how sensitive a certain part of the body would be. In our map, if you have to look at the picture of the body that our brain holds, our hands are huge, the head is bigger, the lips and the tongue are huge, the genitalia. So those are the parts. That's why when you get a little paper cut in your finger, it hurts so bloody much, or something sore on your tongue, because those have a sensory representation in our maps, our parietal maps, much bigger than, say, for instance, our body, our legs. The grazes on my legs don't hurt nearly as much as the paper cut in my finger. Okay, temporal lobe, which is here on the side, obviously kind of really involved in our audio, our hearing, and our recognizing of sounds. It also is involved in visual processing, and very much involved in learning. And then our occipital lobe, which is back here, he's more to do with our eyes, our visual processing, our major visual processing area, which allows us to recognize things, and spatial awareness. It holds that one holds a map of our world. So it holds this idea of spatial awareness. For example, when you go to put your key in the car door in the dark and you can just go right in, your map tells you where that is. Your brain has remembered the angulations that you need to make to get right there. Okay, insular lobe. He's the 5th one, and he is deep to the occipital lobe, so he's deep in the middle, and he's a very interesting one. He's greatly involved in homeostasis. So if you caught the class the other day, we were talking about parasympathetic and sympathetic tone of the nervous system, and he's greatly involved in trying to balance our parasympathetic and our sympathetic states. It's also our consciousness. It's a part of our emotional brain, and interoception, which is how we sense inside, trying to feel those subconscious, proprioceptive. That's all part of interoception, feeling how you feel on the inside, what things feel like. And then also hand-eye coordination. So emotional brain lands in there too. So a little bit of gut stuff, right? So, okay, those are the 5 lobes of the brain. Then you have the thalamus. The thalamus is like a relay station for all the sensory info, except smell. So all our senses land in the thalamus except for smell. It helps to regulate our sleep and our wake, and our hormones. So then we have the hypothalamus, which is deeper to that. This is kind of like down under the insular lobe is the thalamus, and then we've got the hypothalamus under that, and that links the endocrine system. That's the tummy, right? The gut, our emotional iCloud. It links that to our nervous system. The hypothalamus links our gut to our nervous system, and of course then goes into the brain, and so then it becomes an emotional thing. It also controls temperature, thirst, hunger, and your circadian rhythms. Your circadian rhythms are your rhythms that you sleep, the routines that you sleep in. So you can then understand why, when your gut is not happy, when your emotions aren't great, you cannot sleep. it's kicked out your circadian rhythm because they all land in the same place in your cerebral cortex. So the brainstem, and I knew none of this stuff. Let me just tell you, I knew none of this stuff a few years ago. Nothing. I've been dancing and teaching and for years, but it's just because I got really interested into it from my own pain state. And I found this, and it's just really interesting. So the brainstem, I know you're probably yawning and going, I wish I'd never asked her. Right, so the brainstem is 3 parts, okay? It is a continuation of the spinal cord, connecting it to the brain. The 3 parts have a complete nervous system of their own, basically. You've got your mesencephalon, your pons, and your medulla oblongata. And they are solely involved in your life maintenance, okay? And they manage that through our cranial nerves, at least through cranial nerves, 10 of the 12 of them, okay? So the cranial nerves are the ones that transduce stimuli from our environment and from our special senses and create responses. So the eyes, the cranial nerves are even involved in our facial expressions. So the balance, sight, sound, taste, smell, touch, those are all our special senses. The pons, that one holds the vestibular cochlear nerve, which is massively impactful on the cerebellum, and we will get to that in another chat. And then the medulla oblongata, that goes over the upper cervical segment, so just FYI. Then I'm going to come to the nervous system. I'm going to try and go a little bit quicker. The nervous system, the central nervous system, like I said to you in the first little chat that I gave, is the brain, the spinal cord, and the brainstem. Then the peripheral is everything outside of that spinal cord, the peripheral nervous system. Our peripheral nervous system has 2 states, sympathetic and parasympathetic. Our sympathetic is our flight or fight system. So basically, it's a fast-acting fuel supply system. Everything is provided more, okay? So it's going. Okay, that's all you really need to understand. That's the fight or flight system. And the parasympathetic nervous system is exactly the opposite to that. It's your rest and digestion system. It's where you get to stop and just react to the stimuli you've had. The brain is constantly striving for homeostasis between those two. Striving for balance between those 2 tones. And that's called homeostasis. So we are constantly striving for homeostasis. It's a bit of a push and pull system. Excitement and inhibition. And that's how it's constantly trying to balance us out. The gut, the enteric gut, gastrointestinal system, it's part of the peripheral nervous system because it functions outside of the brain and the spinal cord, even though it is attached by the big major vagus nerve, which is parasympathetic by nature. The vagus nerve, it fires directly into the insular lobe where our emotions lie, right? So insular lobe and into that mesencephalon. And then afferent signals, those sensory signals from the gut, influence our reflex, our regulation in moods, our pain perception in the central nervous system, and basically, at the bottom of it all, our emotions affect everything. So our emotions are linked to our organs. That's what I want to say. So when you're in abdominal discomfort, it is often the case of the sympathetic tone just being too high, and bringing that down, helping your body to bring it down to more homeostasis will help your gut. And I hope to give you some tools in doing that. Some of us have already done them. I'm going to stop right there and just do a little bit now. So wherever you are, just find a lovely tall seat. Breathing drives parasympathetic state. So just taking a lovely deep breath in, widening the base of the ribs. And just breathing out, and letting those shoulders just hang heavily from the top of your neck, and bring that head back slightly, lengthening the back of the neck, shortening the front of the throat. And as you breathe in, just try to widen across the chest. And softening those lower ribs down, and just gently finding the pelvic floor and the lower tummy muscles as you bring it down, bringing the tone down. I'm going to ask you to close your eyes and just tap yourself on the head, shoulder blades, sacrum if you can get there comfortably. And just take a nice deep breath. Give me a roll down. I'm in the chair, so I'm just going to do a small one, just focusing on the vertebra that I can feel moving. And then when I roll back up, just feel my feet contacting the floor. And peel yourself up, feeling the vertebrae stack themselves like puzzle pieces, and the head back in line. So that already is just a little summon. Obviously, if you've got real gut pain, you need a little summon more. But just to bring your system down, to feel a change in tone. Basically, the cerebellum is where it becomes very interesting for us with our training and how that works. That's the last part of what's going on up here. And it is parasympathetic by nature. So by stimulating parts that drive the cerebellum, we can drive our parasympathetic nervous system. And that's really cool. That's it. That's what I wanted to say today. I'm sorry, it was really, as I said, it was going to be dry neuroanatomy. If you grab a picture of the brain online and you can look at what I'm saying, that's even better. You'll visualize it. But I hope to make the next one a little bit more what you might feel relevant to how you can help yourself forward. I hope in the next one I'll give you a lot more tools. This was just giving you an idea of what was going on. And if you have any questions at all, and I'm going to need some encouragement on this one because I'm feeling a little bit like nobody's going to even want to watch it this far. But yeah, just by all means, just let me know if you have anything. Thank you.